All right, so next topic is D sugars. And so the interesting about sugars and other components of life is that the degradation of all of these compounds leads to a certain enantiomer. So in this case, the degradation of all natural sugars leads to D-glyceraldehyde. We don't get any of the L version. So let's take a look at how we take a look at this. Again, it's our most popular sugar, D-glucose. And really the only part that makes it D is this last chain. If this last chain is D, basically has that OH on the right side, or is the R enantiomer, then you have a D sugar. And again, only D sugars are found in nature. The L versions are easily synthesized in lab, but they are not found in nature. The reasons for that are unknown. Of course, there's various hypotheses with different amount of evidence for each. And if you'd like to read into that, feel free to do so. Also note that this D has nothing to do with the way it bends light. It just means that it comes from the D-glyceraldehyde. So doesn't have to do with bending light. So for example, L-glucose, which would be the enantiomer, is not found in nature. Remember that in order to have an enantiomer, all of the stereocenters are flipped. So all of these stereocenters would have to be flipped. If you only flip one of those, then it's a different type of sugar. It's no longer glucose, it's something else. We'll take a look at that in a minute. So the cool thing about, like L-glucose, the enantiomer, is that it has the potential as an artificial or for a calorie-free sugar. Your tongue can't tell the difference between these two enantiomers, so they both taste sweet. However, your body does not have the enzymes to break down L-glucose. And since your body can't break it down, it cannot be used for energy. So pretty cool idea there. The reason that it's not used is it's too expensive. There's just cheaper ways to make artificial sugars than having to make the enantiomer of this. And then here's just all the different hexoses. So you can note they're all D versions, right? So these are the naturally found ones. And you can tell in each one, the last stereocenter is with the OH pointing towards the right. Notice that as soon as you change one stereocenter, they just get a different name. So for example, glucose here and ultrose have two stereocenters flipped, and then they just get different names, right? Both of these stereocenters are flipped. The other two are the same, and vice versa. So you can see the sugars can have all kinds of different names. And if you take a biochemistry course, you may be required to memorize all of them. I don't have them memorized. I don't expect you to memorize them.